Hey everyone, so we're just going to go over some of the Calc questions, practice questions. So let's start off with number one. So it says ibuprofen oral suspension 400 milligrams PO one time. So this is just a one-time order. And the medication available is labeled 160 milligrams per 5 milliliters. So how many ml should be administered per dose? Well, let's look at so how I would write them down is the given here, okay, given equals the order. Now you can actually do it the opposite order and given, but this is how I would do it because it's a bit easier for me. But again, every style is different. So we have the given here of 160 milligrams per 5 ml. And what's being ordered is 400 milligrams. Okay, so we have the given over here. We have the order right here of 400 milligrams. It's asking how many milliliters. Now, you can use X as your variable, but you can also use V because ml is considered volume, and then volume starts with a V. So I would actually use this one rather than X because if you use X, you might easily get confused and you might end up with the wrong units. But since it's a computerized test, you don't need to worry about the units. Just write down the number. So as we're going back to the first question, so the first thing you do is just like pretty much cross multiply. So this times with this, and then this times with this. So 400 times 5 is 200. Oh no, sorry. 400 times 5 is 2,000. Okay. Equals this times the variable. So it's 160 V. Now, to get the variable itself, you divide only the number that has the variable. Do not divide by this number because this doesn't have the variable. This number has, so you divide it by the variable. So just 160 in this case. Okay. So, of course, this cancels out. So if you use your calculator, now, in terms of calculator, make sure that you bring the simple one. So this is recommended. Do not bring this. This is programmable, and they might think if you use this, you might be cheating. So that's why on the exam, you must use a simple 8-key function calculator, or just basically known as the basic calculator. So going back here, after doing the calculations, you should have the volume. I'm just going to put it right here. Volume equals 12.5 milliliters. So this is the answer right here. But if you were to put it on the computer, you just put 12.5. Do not add the units at the end. Just type in the number. Otherwise, the computer will give you some funky responses. So again, if you were to do it on the computer, you would calculate, use a scratch paper, and then when you come to your answer, direct answer, you just put down 12.5. But if it were a paper exam, you should write the variable, the number, and the units, correct units. But in the computer, since you just type only this number. Okay, so let's go over number 2. Number 2 is asking that Penicillin G Benzathine 36,000 units IM one time is ordered. The pharmacy sends a 2.4 gram vial of sterile penicillin G powder with the following instructions. For IM use 2 milliliters of sterile water for injection and shake well. The resultant mixture should be 1,200 units per milliliter. How many ml should be administered per dose? Okay. This is where you should always read the question carefully because there'll be some numbers that might be irrelevant for the calculation. So I'm going to show you an example. So let's work this out. So again, you would write down order equals given, but given equals order. That's what I would do. So it says here that the resultant is 1,200 1,200 units per 1 milliliter. So this is the resultant. This is, let's say this is the given. And then you have the order of 3,600 units. Okay, so this is the given. This is the one that the doctor ordered. Now we just have to find the volume. So again, I'm just going to use V again, but X is okay, but you know, just don't, to avoid confusion, you can use V as well, because ml is volume. Okay, so this is what I was talking about with the irrelevant information. Pharmacy sends a 2.4 gram vial. Okay, it's the description of the vial. You need to worry about that. And on the instruction it says 4 IM used to add 2 ml sterile water. It's part of the directions. It's not part of the calculations. So just always read the questions so you know which number you use to calculate. Do you see any 2 grams here? 2.4 grams? No. Do you see any 2 ml here? No. So again, always read the questions, know which ones are irrelevant, and then you should be able to get the correct answer. Okay, so same step, we just cross multiply as always. So you have 12,000 V equals 3,600. When you divide, again, divide where the variable is. Okay, so this cancels out, and you have the volume of 3 ml. Okay, now if it were a computer, you just type in 3. Do not add the ml, do not point 0 at the end. If you do, so you might have a habit of doing this, but the computer might think you put down 30 when it's supposed to be 3. So again, try not to be so fancy with your answer. Just stick with the 3. Don't put 3.0. Otherwise the computer will just falsely accuse you of putting the wrong answer. So in this case, the answer is 3 ml. In the computer, you put 3. If it were a paper exam, you just write down the variable, the number, and the units. But again, it's a computerized, so just put the number only. Let's look at the third one. So it's a Solumedrol 20 milligrams IM stat is ordered. The vial on hand reads 40 milligrams per milliliter. How many milliliters should be administered per dose? So, same idea. All right. So the vial that's ready is 440 milligrams in 1 ml. All right. And the doctor ordered for 20 milligrams. All right. So we're just gonna find the volume. Same deal. Cross multiply. Okay, so again, always divide from the number with the variable, not the one without the variable. So you might be thinking, okay, because this thing is bigger than this. 40 is bigger than 20. Okay, I think I'm gonna divide 20 because I'm scared that I'm gonna get a weird answer. No. You divide the number where the variable is. So it's not going to be 20 that you divided. It's going to be 40 because 40 has the variable. 20 does not. And I know it's going to be like a number that's still funky because it's going to be less because this is bigger than that. But hey, it happens, right? So this is going to be your answer, 0.5 milliliters. Again, you type in 0.5 to add the units at the end. Okay, let's look at the next question. Okay, so it says, this one says, Clindamycin 900 milligrams, PO every 8 hours is ordered. Available is Clindamycin 300 milligrams. How many tablets should be administered per dose? Okay. So we have here, you have this one at hand, you have 300 milligrams Okay, in one tablet. Now, this is not a volume. It's a tangible thing that you hold, that a patient holds in their hand, or the nurse holds in their hand if they administer it. So, 300 milligrams in one tablet, and then the doctor ordered clindamycin in a 900 milligram PO. Okay, so again, always read the instructions. So we have another kind of like an irrelevant number, 8 hours. That one you don't need to worry about that. You just focus on the one that's available and what the doctor's ordered. Whether the times and whatever, just ignore it. Okay, so this is a tablet. So since this is a tablet and tablet starts with T, I can put a T. You can put X, but to avoid yourself from confusion, I just put T for tablet. So same deal, we just cross multiply. So 300T equals 900. Okay, then you divide it by 300 because it has the variable. Okay, so T is equivalent to 3 tablets because 900 divided by 300 is 3. Now, in the computerized exam, you put 3. Do not include the label at the end. If it were a paper exam, you'll just write the whole dang thing. But computerized, guess it's going to be mainly in computer, just write down the number 3. Okay. Alright. Let's look at number 5. We have Pepsid 40 milligram IV bolus that is ordered. Available is Pepsid injection 20 milligram per milliliter. How many ml should be administered per dose? Okay, so let's write down the given or write down the order, wherever fits closer both. So this given 20 milligram, if you can see it. Okay, 20 milligram. Okay, just have to creep it up there. Okay, 20 milligram in 1 ml. Got that? Okay. So the doctor ordered 40 milligrams. And it's asking for how many mLs. Same deal. Cross, multiply. So this, you bring this down, you have this. You bring this down, you have this. Alright. See that? Then you divide where the variable is. So you have the volume of 2 ml. In the computer exam, we type in the number 2. Paper exam, you write the whole thing. But again, just focus more on the computerized. So just put down this number. Do not add the units at the end. Okay, so number 6, it says a patient consumed the following for breakfast: 10 ounces of water, 8 ounces of juice, and 10 ounces of coffee. How many ml should be recorded in the intake and output record? So this is in and out. You're going to do a lot of this throughout every shift to see how much fluids, how much food they consume in, and how much they put out. So if you're to give like food for breakfast, lunch, or dinner, it just goes by 25%, 50%, 75%, 100%, or even 0% if you refuse. Add the amount of the liquids given. You just look at the how many mLs are in each fluid, and yeah, I just do some additions so you can find out how much it will intake. And then when you do like an output, like for instance, if you were to empty out the urine from the catheter, it shows you how many mLs of urine it puts out. So usually in cc's or mLs, but there's a little practical thing to keep in mind. But focusing on to this Calc. So we have, okay, again, it's good to read the questions because you have two things that are in 10 ounces. 10 ounces of water and 10 ounces of coffee. So I'm just going to do one time, okay? So we have 10 ounces. Okay, so this is where we start using conversion factors. I'm going to put this out here. Okay, Yeah, so make sure you know all your conversion factors and try not to switch the numbers, okay? Because I'm going to show you right now. So, in 1 ounce, you have 30 ml. Keep this in mind. 1 ounce equals 30 ml. As I mentioned earlier, do not switch the digits. That's when you're going to have very funky answers. So, 1 ounce is 30 ml. Not 30 ounces equals 1 ml. To be honest, I have done that before. I tend to switch the 30 over here. Always thought, okay, 30 ounces in 1 ml. Only to find out that this is the correct one. So if possible, don't fall into the trap just like what I did. So we want this into mLs because the question is asking how many mLs. What do we do here in order to get the ml? Remember, we have an ounce, so how are we going to do that? In other words, another question to consider is, where do we put the ounces? Do we put the ounces here, or do we put the ounces here? Do we put it on the top, or do we put it on the bottom? Correct, we put it on the bottom. So, as I mentioned earlier, 1 ounce is 30 ml. So we put 1 over here. See the number 1? Okay, it looks like a number 2. Okay, it's enough. It's 1 now. And then we put 30 ml on top. Now, all we do is just cancel out the ounces. Always put on the bottom. Yeah. So, then we just cross multiply. Just multiply through. So, 30 times 10 is 300. Or if you can use a calculator, but here's a trick. We know for sure this one has a 0 and this one has a 0. So how many zeros do we see here? 2 zeros. So we just focus on this. 1 times 3. 1 times 3 is 3. And how many zeros, as I mentioned? 1, 2. You drop the 2 zeros. So 300 ml. Now, as I mentioned earlier, we have 10 ounces of water and 10 ounces of coffee. So since those two liquids have 10 ounces each, we can actually multiply by 2. So we have 600 ml, because 300 double is 600. So here we go. Now, let's put this in the upper corner so we won't forget. So remember now, put something in the corner right here. 600 ml. Okay. Save that for later. Now you have 8 ounces of juice. So same manner. So 8 ounces. And as I mentioned earlier, we put it the units on the bottom in order to cancel out, and we have the ml because it's asking for ml. Okay, so we have 1 ounce here and 30 mLs here. Same deal. They cancel out. So how many ml is that? Okay. There's 1 0. There's 1 0. 8 times 3 is 24. And how many zeros do we have? 1. So we just drop that 1 0 right there. 240 ml. Okay. So let's put this down right here. All right. So now we have these. This one from the 10 ounces of water and 10 ounces of coffee. Here is from the 8 ounces of juice. All we have to do now is just add them up. So we have 600 plus 240. Okay, we have a 0 over here, we have a 4 over here, and we have an 8 over here. So let me just, so this is from 10 ounces of coffee, 10 ounces of water, and this is from 8 ounces of juice. Okay, so this is how we come up with these numbers. 600 plus 240 is 840 ml. So this is going to be our total. This can be our answer. Computer exam, you just put down 840. Don't mind the mLs. Don't even think about putting a 0.0 at the end, because if that's the case, they're going to think, the computer will think, oh, holy cow, 8,400 ml. No, it's 840 ml. So again, don't let the computer confuse itself. Just put 840. Don't do anything fancy or technical. Okay. Let's see what's the next one. Okay, so we have Lanoxin 1 milligram daily is ordered. The medication is applied at 250 microgram tablets. How many tablets should be administered per dose? Okay, this is another conversion factor. So we have micrograms involved. We have milligrams involved. Okay. So I just think, okay, if we have 1 milligram, how many is that in micrograms? Yes, it's 1,000. Yep, 1,000 micrograms. Okay. You have the conversion factor, right? 1 milligram is 1,000 micrograms. Okay. Keep that in mind. All right, so we have 250 micrograms. This is the given. Yeah? 250 micrograms. And then I want milligrams. Again, where we put the micrograms, do we put it here or do we put it here? Do we put on the top? We put on the bottom. Which one? Which one? Which one? Yes, it should be on the bottom because we want the milligrams. So this will cancel. Let me cancel beforehand like that. So 1 milligram, as you remembered writing it down, is 1 milligram equals 1,000 micrograms. So this cancels out. So if you do, so it's 250 times 1 divided by 1,000. So that should be equal to 0.25 micrograms. Oh, sorry, 0.5 milligrams. Did I say micrograms? I meant milligrams. Or here's one way to do it. You can do it with a calculator, or we have 1,000. So if you divide anything with the zeros, whatever zeros at the end, that's how many places you have to move to the left. So we have 250 divided by 1,000. So we have 250 right here. The decimal is right over there. We want to divide by 1,000. So how many zeros do we see here? 3 zeros. So we move 1, 2, 3. That's how we get 2.25 milligrams. Got it? Okay. Now we know we have the milligrams already settled. So it's 0.25 milligrams. Okay. Okay. 0.25 milligrams. Okay. Let me just write a bit lower so you guys can see. Okay. Now this is going to be in 1 tablet. So since it's tablet, you know what variable I'm going to use, right? So the doctor ordered 1 milligram. So this is what the doctor ordered, 1 milligram. And of course, the variable at the bottom. Okay, so just like so, we cross multiply. So 0.25 t or x, whatever floats your boat. And 1 times 1. Any number times 1 equals itself. Remember that. Okay, so 1 times 1 is like 1 is multiplying itself. There we go, 1. So how many taps is that? So we just divide both sides by 0.25. You can do a calculator, but here's a trick, another math trick. I'm sure you probably learned this in your elementary or intermediate school. We have a decimal number here. Put this right here. We have a decimal number right here. It's so we're going to divide by a decimal number. Sorry, we're going to divide by a decimal number. How are we going to make it look like we're going to divide it by a whole number? Look at this. The decimal place is right here, and there's like 2 numbers behind it. So we move 1, 2. So it's going to look like we're putting 25 over here. If we do it on one number, we have to do it to the other number. So the decimal point is right over here, so it's right there. So we just move 1, 2. And then we just, and with this empty voids, we put zeros. So it's going to look like this. So you see? Let me put it a bit lower so you can see. It's going to look like this. 100 divided by 25. 100 divided by 25 is 4. Okay? So, let's apply to this concept. If we know that 100 divided by 25 is 4, then 1 divided by 0.25 is 4. So on the computer exam, you just type in 4. If it were a paper exam, you would probably put the whole thing. But again, I know I'm speaking so repetitive on this, but it's a computer exam. It's going to be a computer exam. You're going to put 4. Okay, so we're done with these 3 questions. Okay, so the last 3 questions involves the IV flow rates. So let's look at number 8. 1,000 milliliters of dextrose, 5% in normal saline, D5NS. IV is to be infused over 5 hours via electronic infusion pump. What should the IV flow rate be set at in milliliters per hour? Okay. So we have the given here. So okay, so we're just gonna put the 1,000 ml to be infused over 5 hours. So what would be the flow rate for 1 hour? So again, now remember, it's asking the flow rate. It doesn't ask the volume. Flow rate. So you might have to write the whole darn units. But again, it's a computerized exam, so just looking for the number. But in real life purposes, you just want to write the whole flow rate units. Okay. So we set at 1 hour. Okay, so I think this is not too bad because it's asking for a 1 hour. I'm asking for 1 hour for a single thing. I don't want 5 decoys coming at me. I just want one single thing. So we cross multiply it. So it's 5b equals this. Any number times 1 equals itself. So 1,000 times 1 is, oh, duh, 1,000. So we divide both sides by 5. This cancels out. So V equals 200. Okay, yes, V equals 200, but you need to write the whole thing. So it's 200 ml per hour. Got it? So just put down 200. Okay, so I've been redirected to another room, so let's continue regardless. So 500 milliliters of dextrose, 5% in water, so D5W IV is to be infused over 2 hours via manual gravity flow. The drop factor of the available IV tubing is 12 drops per milliliter. What should the IV flow rate be set at in drops per minute? So we're going to do some conversion, and then we end up with the units of drops per minute. So we know for sure 1 hour equals 60 minutes. Okay, but now in the question it says we want minutes. We want, it gives us hours, but we need minutes. So we just use the conversion factor. So if we have 2 hours, so multiply by that by, okay. Again, we put the hours here so the units will cancel out. As we mentioned, it's 60 minutes in 1 hour. Okay, so we multiply, so 2 times 60 is 120, and then divided by 1, any number divided by 1 equals itself, so it's 120 minutes. Keep that number in mind as we work on through the problem. So 500 ml, so that's the amount of D5W divided by 120 minutes. Okay, now we have here the given drops per milliliter, which is 12. 12 drops per milliliter. Okay, so we're here, we see two division signs. We have a unit on the top, and we have a unit there on the bottom. Top and bottom cancels out, so we can just cancel the mLs. So we just work it through. So 500 times 12 is 6,000 divided by 120. Okay, so instead of the zeros, we left with this. We have this one 0 over here. 16 divided by 12 is 5. And then there's another 0 at the end. So we have 50. So you can type that down, 50. But we need the units if we were to write it down. So we have drops per minute. Again, it's a computerized exam, so we would put 50. Right? So let's look at the last question. And that is, vancomycin 2 grams and 250 milliliters of dextrose 5% in water to D5W IV is to be infused over 50 minutes via electronic infusion pump. What should the IV flow rate be set at in milliliters per hour? Okay, so we have, so of course we can do those conversions, but is it necessary? I'll show you what I meant. You can do this. You can do this. I mean, you don't have to, but you can do this. So, of course, the units will be canceled. So you're going to be left with this. This is sometimes what I don't like about using such conversion factors. You're going to be stuck with a repeating decimal. Okay, so this is what's going to ruin the solve. When you're trying to solve it, this is what's going to ruin it because it's a repeating decimal. We cannot round, so everything is be all mambo jumbled up. So just keep it simple and just use the minutes instead of the hours. So it's going to look like this: 250 ml. All right, infuse over 50 minutes. And remember, 1 hour is 60 minutes, so we just put 60 minutes right here. All right, empty volume. So oil is just cross multiplied, so it's going to look like this. So 50V equals 250 times 60 is 15,000. Okay, so V, we divide both sides by 50, you should have 300, sorry. V equals 300. Okay, but it's asking for milliliters per hour, so we just write it right here. 300 milliliters per hour. Now, if it were a computer exam, we just put the number. Don't put the units, just put the number. And that's it. That's pretty much concludes the medication calculation. So if you have any questions, don't hesitate to shoot me an email. Other than that, I wish you luck in the MedCalc exam.